All right, so today we'll go over our next topic, which is the branch instructions. Now, you remember the last time we covered the flags. So this is the time to see how the flags are so important. So you will start looking at it carefully right now and understand how the flags are affecting the instructions and the branches. Let's see. All right, so today we will learn about some new kind of instructions called branch instructions. Now these also belong to the same list of those 6 pages of instructions. Now what are the difference then? We already know the regular instructions. Why we are treating them as a different instructions? We'll also show you that, and also you will see that how the flags are so important to understand and to work with such branch instructions. Now, so far again, as a reminder, we have this list of general purpose registers. We have explored accumulators. We have explored condition code register because we know the flags right now. I think still we don't know exactly what is the purpose of index register, what are the purpose of stack pointer and program counter. Now today we'll probably know a little bit more about the program counter. So what is program counter? Again, you have seen it before that the program counter is a 2-byte register, okay, that holds the address of the instruction that microprocessor will execute next. Again, this is a little bit different than other registers, because what happens about the other registers, most of the cases are you control the registers, you basically load something there, okay, and then you add or subtract or you do other operations with those registers, right? Regarding the program counter, now this is again a 2-byte register, but you are not the one who is controlling this register. Instead, microprocessor is controlling it. Now how? Let's say if your instruction, so I think this is a good slide that I can use to show you that example. Now remember, we have already seen similar example in past, but not with the last column, okay? Now these are your instructions. You see here under the source code, these are the lines of instructions you are trying to execute, okay? Now when you have some instructions, you know that all the instructions have some addresses, okay? All the instructions have some addresses, okay? So you see these in the very left column, you see we have listed all the addresses of the instructions, okay? Now starting from, we assume that we started from 0000. Since each instructions are taking different bytes, we know that from the object code, right? Let's say the first instruction is taking 2 bytes, so this is 2, because this is the address of 86 is 0, address of 23 is 1, and the address of 8B is 2, 3, 4, 5, 6, 7, 8. This is how we read the addresses, because each of these object code, I'm saying each of these object codes, either it is taking either 1 byte or 2 byte or 3 byte, because we know how to write the object code from the instructions. Now we know their addresses, but interestingly, if you look at the last column here, very last column, you'll see what we have here is in the first line we are writing 0002, which is basically the address of the next line. Next line we have 0004, which is again the address of the next line. Here the PC in the third line, the PC is 0005, which is the address of the 4th line. See, the starting of the 4th line is 5, right? So every line when you are in some line, the PC, which is the PC register, program counter register, that holds the address of the next line. Okay. Now, why do you need the address of the next line? That might be another interesting question, that why you need the address of the next line, because you might know that what will be the next line automatically. Now, we have some reason why you need that. Okay. The reason might be, let's say you are running a loop. I'm sure that you know the loop, right? I'm saying you heard the loop about the loop in the C++ class. Remember the loop. You have, what loop you used to have? You had for loops, while loops, right? Do while loops. There are several other different types of loops, and also there are control structures like if, else. Remember? In case of those things, what happens? You basically repeat a bunch of lines again and again, right? Remember that? So what happens? You are not basically following the lines sequentially. Instead, you are repeating some lines, let's say, for a specific number of times, right? Bunch of lines are repeated again and again, let's say for 5 times, 10 times, 20 times, based on how you need them. Similarly, in the low-level language, we also have loops, okay? They are called branches here, okay? And sometimes you might want to skip some lines, you might want to jump. So those, in case of those instructions, this PC counter is really, really important, because it will hold the address of the next line where it will be jumping, because you might be skipping the next line, and based on your decision, I'm saying based on some loops, you might be repeating some lines, so you might be jumping around in different lines instead of executing exactly the next line. You know what I'm saying? So then the PC counter is really important, and that's exactly why the PC counter is introduced, and that is exactly how your microprocessor knows what will be the next line to be executed. Okay? So that means any branch instruction basically will tell PC register which will be the next line to be executed. Now, today we'll look at some of the branch instructions as well. So first of all, before we start, we need to know a couple of more things as well, to understand the branch instructions here. Number one, what the branch instruction does. If you try to put it formally, it basically transfers the control of the program to another part of the program. What do you mean by the control? Basically, the line that is being executed, that is like at this point, that is the control of your program. So it basically jumps around. So for an example, we use something called labels. I think we have heard about the labels so far, but we haven't, I think, explored it yet that much. For an example, let's say you can write, remember, when you write the program, you use a tab, right? Use a tab and then you write your instructions. The reason you use a tab, because all the first columns, all the first several columns, you keep those columns just for writing the labels, okay? Just for writing the labels. So here, in the left side, you are writing the labels, right? And look at somewhere, let's say here, the BRA, this is a branch instruction, okay? Now, if you look at here, the BRA, you are writing BRA and a label name. Now, label names are just like names. You can give any names, whatever you want. Now, what happens when your program is in this line, since you have written branch to this line, automatically your program will jump here, skipping all the lines in the middle. Okay? So this is how you basically do some kind of control structuring or looping, if you want. You can jump forward, you can jump backward as well. I'm saying you might want to repeat some lines just like the loops. Remember the loop, what happens? You just have a bunch of lines. You are repeating those lines again and again. And to repeat those, what you need to do, at some point you have to go back, right? So again, just using the loop, labels, and branch instructions, you can jump back and forth, depends on how you need them, okay? So again, branch instruction always follows the labels. Doesn't matter what kind of branch you have, there are plenty of branch instructions based on different things. We'll explore those again, so we'll need probably a couple of weeks to understand all of the branches, but this is a very basic one. I just tried to list one just to show you that how the branch instructions might work. So here as well, remember, anytime you have any kind of branches, your PC register will hold the address of that line where the branch will be jumping. For an example, look at this here. Now we have modified a little bit. These are the addresses of the line, right? And your lines are all under the source code. And in the third line here, JMP save, you see the save is a label, okay? Label can be anything, that's just a name that you can give. It's up to you what name you want to give, okay? Now you see the save is, there are a bunch of lines in the middle, okay? Save is here. This is a label, okay? Now in the middle, you see there are plenty of lines. How do you know? Look at the addresses. The point we finished the first table, the address is 0004, right? And the next table is starting from 0200, which is far apart from 0004, right? See what I'm saying? So in the middle, there are plenty of lines. Now, let's say for some reason, you have something so that something like you want to jump here. So that's why you are writing JMP save. So in the code, you are writing JMP save. But what happens in the PC? In general, the PC is supposed to be going to the next line because, automatically you always go to the next line. That's the default situation, right? So the next address should be 0007, right? How? Because this is 4. So the address of 7E is 4, right? The next line is 5, and then this is 6. So the next line should be, after this line, the next line should be starting from 7. So the PC should hold 7 at this point. But since you are jumping to the new label, this 7 is replaced by 0200, which is the address of the line where the save is. You see the save here? And the address of that line is 022. So that's how basically the PC is the one which is automatically updated. Remember, you don't have to update the PC. All you need to do is you have to write your branch instructions, you have to write your labels, but inherently those branch instructions will be updating the PC so that your microprocessor knows which will be the next line to execute. That may not be the next line. You see what I'm saying? In general, so far, we used to see, oh, okay, the next line will be executed, the next line will be executed, but now this is not the next line. This might be a line after like 20 lines apart from here. It may be like backward, it may be forward. So we don't know exactly. It depends on how you are writing the code. Okay? So that means it will always not be the next line. It will be the line where you want to jump. Mm-hmm. You just have to write a line there like this. Let's say you will be writing, let's say, jump and the label name. Anytime you just write a branch instruction or a jump instruction, these are called branch instructions or jump instructions. If you just write those lines, from those lines your program will be jumping. Okay? You see, we are jumping from the line where it is written JMP save. That means your program knows from here it has to jump to a label called save. Save is a label. That's a name. Don't assume that save is a keyword. It might be your name. It may be something else. It's just a word. It's just a name that you give, okay? So let's say, so automatically, since the save is written here, it will look for the label save. And all the labels are written at the back, at the left side. You have seen it, right? Remember the lab 1, you have seen a couple of labels written at the left side. So because we start the code from the column 8, so all the columns before that is basically reserved for writing the labels, if you have to write any. You don't write labels for every line, but you might have labels in different lines. So at this point, I think here, so this is, this is exactly what I wanted to say. Look at this. Instead of 0007, it's replaced by 0220 because the program will be jumping from this line to the line where the label save is. See, you don't have to replace anything. See, all you will be doing is you'll be writing the code. Okay, you don't have to modify the PC register. It's automatically modified by your code, by your compiler. See, look at this again. You are not modifying the PC register. That automatically modified. All you are doing is no. All you are doing is you are just writing the code, nothing else. All you are doing is you are writing only these two columns, okay? The column with the label and the column with the source code, because you can only write the source code, right? And you can only write your labels. But inherently, when you are writing the labels, the program will be jumping, PC registers are being changed. You know what I'm saying? But those are done automatically. And this is, at this point, I'm just, I got a chance to explain how the PC register works, because we have been watching all those list of registers, but we have not explored all of those. So this is one of those registers. That's why I'm explaining why the PC register is important and how it works basically. But you don't have to do anything to modify the PC register. All you need to do is write your code, write the labels. But also you have to understand where to jump. Those are based on logics you need or how the program you want to write. We are assuming that the 007 will be the next line. Because how it will be next line? Look at this. The address of this line is 4, right? 0004. So which means 7E, the address of 7E is 4. Address of 02 is 5. Address of 00 is 6. Automatically the next line will start from 7, right? So, that's how we gave like the default address of the next line. But it will be replaced by 0200 because you are jumping on that line. You are jumping to another line with the label save. But remember, all this PC register, you will not see it there in the program. I'm saying inherently it is happening. If you want to see, there are ways to see what is the data or what is the address is loaded into the PC register, but we always want to understand how the PC register is working, how these things are going, because you probably want to know, because at the end of the day, all of these are like bunch of binary numbers, or you can think it as hex, but how the microprocessor knows where to jump. The only thing that the microprocessor does is it reads the PC register, you know what I'm saying, and it knows exactly where to jump. And how the jump is controlled. Jump is controlled just by how you write the code. So the most important for us to understand how these jumps or branch instructions work. Within a moment we'll see it, in fact, how those work, and we are going to those directions. Now here, I wanted to show you that labels can be anywhere and you can be jumping anywhere. You can be jumping forward, you can be jumping backward. So all the forward jumpings, those are called jumping or branching, those are called positive branches. Okay, for an example, in the first one, you see our branch is here, label is here, and the label is appearing later on. Do you see what I'm saying? You are branching, this is the line where you are branching, okay? Do you see the line BRA label 1? Your label 1 is appearing later. In the next example, which is a negative branch, you see here, the label is here, BRA label 1, but branch label 1 is already appeared, right? It has already appeared, right? So what we have in the second category? In the second category, when this line executes, you'll be branching here, right? Backward. Because you probably want to repeat a couple of lines again. You know what I'm saying? It's similar to the loops. Think about the loops, because all these are coming into the picture because of the loops. Because in the program, we might want to run some of the lines again and again. We know that, right? We might have to do that, just like how you did in the for loop, while loop, do while loop, and even if-else structure. Remember? Because you want to, you might want to, what happens in the program? You might have something, and based on that, you probably want to run a bunch of lines, or you want to skip some other lines you probably want to run. So you probably want to choose between two blocks of codes. So that's why we need those branching. So, and again, branches have two other branch instructions have two categories, because as you know, we are just going to start looking at all the branch instructions. We have like a list of branch instructions, all those in the set of instruction list. Some of the branches are unconditional, okay, which are like only two. One is JMP and one is BRA. Now what does it mean by unconditional? Meaning anytime you write them, your program will branch for sure. Doesn't matter what happens, your program will branch. But some of the branches, which are most interesting ones, those are conditional, and these are more useful. What do you mean by conditional? By conditional we means we used to check something there, and based on the check, based on the result of the check, either it will decide to branch or not. For an example, what you did in the high-level language, you have written something like this. Remember, if x equals to 0, do this. Now what is your checking condition here? X greater than 0. So that means anytime if the value of x is greater than 0, then only these loops occur, right? Is it reminding anything? Remember in the bracket. So I think you might, I'm not sure you see it here. So you may have like this, right? Then you have a, I'm just showing you the code from C++, because I know that all of you have seen those codes. So this is what? This is the condition, right? So if for an example, for some reason, if the x is not greater than 0, what happens? This loop will never occur, right? So similarly, in the conditional branching, we have some criteria or conditions to meet. If they do not meet, your program, I'm saying your branch will not occur. So at this point, since we are just starting, we are basically interested about those conditional branches, okay? And we'll explore those one at a time. Maybe a couple of ones here, and we'll be doing a lot of quizzes. We'll see how those works. Now, again, from here we'll be discussing only on the conditional branches. Now, first of all, conditional branch means, again, branch if the test condition is met. Again, the test condition is like the condition for which the branch will be jumping or branching or not, okay? Now, the test conditions, how do you know the test condition of the branches? You will always get the test condition of the branches in the third column of the set of instructions. I listed it here again because, in the third column of the set of instructions, we have like a technical description of the branch. Similarly, technical description of the other instructions as well. We have explored the third column so far for the other instructions, not for the branches yet. So we'll always look at the third column. Now let's look at this bunch of lines here. So for an example, this is our example 1. Let's say we have 3 lines here, okay? Now we know the first line, that is what? The LDAA, we know that, right? We understand that line. Second line is ADAA, which is an addition. Whatever data you are loaded in the A, you'll be adding 34 with that. So in the third line, we have a branch instructions, BMI. And you see, with every branch instruction, there will be a label, right? I'm saying it might be anything, just a label, which is a name. Let's say the label is saved here. Now, we have to decide here whether the branch will occur or not. Again, as I said, these are conditional branches, okay? So first of all, what is the condition? We have to look at the third column of, if you have the set of instructions, please look at BMI just to make sure. Just look at the set of instructions and look at BMI to see whether you find the test condition, which is n equals to 1. All right, so if you look at BMI, you will see in the column 3 is written n equals to 1. That means what? What is n? Is the n flag. This is where the flags become so important and flags come into the picture, okay? So n is a flag, we know that. This is a negative flag, right? This is the negative flag. Now, what is happening here? So you have to first check these lines, and you have to see whether the n flag is set when you are in this line. You are in the third line of this in this code. Okay. Now, if you look at all the three lines starting from the line 1, what happens in the line 1? In the line 1, 20 is loaded. 20 is the data, right? 20 is loaded into accumulator A. In the line 2, you are adding 34 with the 20, right? This is an addition. Now, we are just, before we decide about the flag, we have to first check what operations are being occurred, right? So the operation is 20 plus 34, which becomes 54. Now decide whether the n is yes or no. Remember the n flag, right? It's a negative flag. Is it set or not set? It's not set because the 54 is not a negative number, right? 54 is not a negative number because everything, negative number starts from 80. Everything after the 80 is negative numbers. I'm saying when you are talking about 1 byte. If it is 2 byte, negative numbers should start from 8000. I'm saying 8000. All the numbers after that is negative. So now, 80 is the negative number. So this is not negative. So n flag is not set, right? We said n flag is not set. So n flag is not set. Now at this point, what does it mean? It means n equals to what? N equals to 0, right? Set means 1. So clear means 0. Not set means 0. So n is 0. Now what is your decision? Do you think the branch will occur? So the branch will not occur because the condition of the branch, look at this last branch. Look at this, the condition is n equals to 1. That means the branch will never occur because n is not equals to 1. You see what I'm saying? So this is what we need to decide at this point. You will see a bunch of lines like this. Let's look at the next example. I have still same lines. We just changed the branch here. Okay? Now, not same line because it's a subtraction here. So this time the branch is BLE. Okay? Let's look at BLE in the set of instruction. And look at the column 3. So in the column 3, you will see the BLE test condition, which is already given there. So look at this. This is a little bit, it's a little bit more than what we have seen before because it's Z plus N exclusive or V. Now all these are the flags. Now this is where you see how the flags are so important because every time all the branch instructions, the conditional branch instructions are, the decisions of the conditional branch instructions are decided based on the flags. Okay? Now, again, you are doing a subtraction here, right? Because you are loading 20, you are subtracting 34 from there, and then what do you get? You get EC. This is the operation you are having. And then after that, what flags are set? I have written all the flags basically because we don't need C here because you see we don't need the C, right? But I just listed all the flags. C flag is set because this is you are subtracting a larger number from a smaller number, so the C flag is set. 0 flag is not set because the result is not 0, right? N flag is not set. N flag is set because EC is a negative number, right? V flag is not set because you have to see this is a subtraction and you are subtracting both positive numbers. Remember, in case of subtraction, we have some categories, right? In case of subtraction, both numbers have to have different sign. Both of the numbers are positive. 20 and 34, both are positive, so V flag will never be set here. So all these flags we know exactly. So now, how can you decide what happens about this? Let's do the math. Little math here. So this is your equation, right? Z plus N exclusive over V. You just plug the value of those flags. I just replaced it by the value. So what happens? 0 plus, in the bracket, replace the N and V. Remember, the exclusive OR gives you high when the inputs are different, right? That's how that N plus V part will give you high. Because N plus V part will give you high because they are different, right? This part. So you are getting 0 plus 1 from here. Okay? Because from here you get 1. Because it's 1 plus exclusive OR 0. So you get 1. So at the end you get 1. Do you see that? At the end, because these are 0 plus 1, which is OR at the end, so you get 1. Now, what was the condition? The condition is this has to be 1. I think the condition is met, right? Do you see the condition is meeting? Because all you did is, this is the test condition. We have plugged the values of the test condition here. And then once you have the test condition, you calculated and you saw that's 1 at the end. That means which is meeting. That means your branch will occur, right? So the answer should be yes. Now at the end, all you have to decide is whether the branch will occur or not. The branch will occur, maybe yes, or branch will not occur, it will be no, okay? So again, just as a reminder, what we did, we first have a bunch of lines like this, and then we found the test condition for BLE from the column 3 of the set of instructions, right? We write it down. We know that this equals to 1. That means if this left side equals to 1, then the branch condition will meet and the branch will occur. To decide that, what we did, we looked at 3 lines. We started from the line 1, and then we looked at line 2. This is a subtraction. This is basically a subtraction because you are loading something into B and then you subtracted from B. So this is just a subtraction. We did the subtraction here. 20 minus 34, we got EC, and we checked all the flags. Okay, we know how to calculate the flags, right? We know the flags. Now, and then we plug the values of the flags here. We don't need the C here, but you know, we need other 3. So we plug those values and we calculated to the N, and we found that that's 1. That means the condition is meeting here, right? If the condition is met, that means what? The flag will, or the branch will occur, okay? At the end, we just have to choose yes or no at this point because we are just starting. Now, look at another example. You know, I'm just trying to show you one more example because, you know, it's a little bit more here. Now, here, we gave you a couple of lines, and we want to know a little bit differently because, you know, this is still the same question, but I just wanted to make you a little bit, you know, think a little bit more here. So the branch you have here is still BLE, okay? But I added 2 more lines after this. You see the full is a label, okay? Now, you have to think this. If the branch occur, okay? If the branch occur, what happens? From the line 3, you'll be jumping to line 5, right? Because you are jumping to full, which is a label, right? Do you see it? If the branch occur, you will be executing line 3 and then you'll be jumping to line 5. But the line 4 will never occur, right? Do you see it? Now, let's say if somebody asks you this question, that what happens, what will be the content of the accumulator? I think I should, there is a typo, I'll correct this one for sure. It's the accumulator B. So let's say if someone want to know what will be the content of the accumulator B after you execute this code. Now, again, everything depends on the loop of the on the branch. Why? Because look at this. From the line 3, if you branch to line 5, what happens? The line 4 is never executed, right? If the line 4 executed, then your accumulator B will be loaded by 25, right? You see what I'm saying? Do you see it? In the line 4, you are loading 25 into accumulator B, right? Now, if the line 4 is not executed, accumulator B will have something else. You know what I'm saying? So that's why we really want to see whether the branch will occur or not. Because if the branch occur, line 4 will not be executed, so you will have something else there. If the branch will not occur, you will basically execute line 3, line 4, line 5 sequentially, right? And then in the line 4, you will have loaded 25 into accumulator B, and then that will be the content of B. You see what I'm saying? Now let's look at again what happens here. We know the test condition of BLE, which is Z plus V plus N plus V exclusive or N equals to 1. We do the subtraction, we know the flags, and then we know the condition is met. Now what happens if the condition is met here? If the condition is met, this is exactly what happens. These are a little bit, you know, because of the big screen. You are jumping from line 3 to line 5. Your line 4 will never be executed. Okay? Now what happens, your accumulator B will hold EC, right? Because after the subtraction, the result was EC. So that's what you will have in accumulator B. Now what happens if the branch does not occur? What will be the content of B? 25, right? Because what happens? EC will be replaced by 25 in line 4. This is what I'm saying? So that's why we really want to understand whether the branch will occur or not. So you'll see some questions like this as well. Because the question will be asking, what will be the content of the accumulator B after this bunch of lines occurs? All you need to see is whether the branch will occur or not. If the branch occurs, something happens, you see, because some of the lines are skipped, right? If the branch does not occur, line 4 will be executed. In line 4, your accumulator B will be replaced by 25. I'm saying the EC will be replaced by 25. So all you need to decide whether it is EC or 25 based on the branch. This is another example. Here is another example. So again, you have 24, 34, and your branch is to save. Again, this is a pretty much similar example. If the branch occur, line 4 will be skipped, right? If the branch does not occur, line 4 will be executed and you will have a different thing in accumulator A. Now, what happens? Let's check the, so if you check the branch condition, the branch condition is what? Test condition is n equals to 1. So what we're doing is we are adding this to number 20 and 34. We add it, and then we got 54. As you can see from here, n flag is set or not set? It's not set, right? Because 54 is not a negative number. N flag is not set. So do you think the branch will occur? N equals to 0, right? N flag is not set. That means what? N equals to 0. And the testing condition is what? N equals to 1. It did not match. So the branch will not occur, right? Since the branch will not occur, line 4 will be executed because you are not jumping. You see what I'm saying? If the branch does not occur, it will be just like the regular line. In the line 3, the branch did not occur. You'll go to line 4. You'll go to line 5 sequentially. If the branch occurred, then you skip some lines and you jump to the level, right? So the line 4 will be executed, and the accumulator A holds 48 instead of 54 because what happened? After you added 20 plus 34, you got 54, and that's what is saved into accumulator A. But in line 4, you again replace this 54 by 48, right? Because the branch did not occur. So, you know, again, these are some questions that we want to see. We want to know exactly to understand the branches. And these are some list of branches from your textbook. I listed in the slide as well, just to know that some of the branches are like this. They are called signed or unsigned branches because conditional branch instruction can treat numbers as either signed or unsigned values because these branches are called signed branches and these are called unsigned branches, or some of the branches are signed or unsigned both. Basically what happens is, all you need to do is you have to check the branch test, okay? Now in the branch test, these are the list of tests. If there are N or V, okay, that means if there are negative flag or V flag, those branches are called signed branches, okay? In the condition, if you see C or Z, those branches are called unsigned branches. If in the condition you see only Z, they can be either signed or unsigned. So what does it mean by signed or unsigned? It means that these branches are basically considering the number as the signed number when the branches are signed branches. When these are unsigned branches, they are treating the number as unsigned number. Okay? But again, you know, this is a little bit, you know, later it will come into the picture. At this point, we will since we are done with the flags, because that was the quiz 6, we'll go to the pause and we'll try quiz 7 sequentially, quiz 8 and quiz 9, because all these quizzes are based on the flags. And again, just like the previous ones, again, stepping 1 more step at a time. Quiz 7, it will be the basic one. Quiz 8 will be a little bit advanced. 9 will be more. So all these quizzes are designed based on the branches. Okay. All you need to do is to understand the branches, understand the test condition, and how to calculate the test condition from the flags. Okay. Any question at this point? All right. So let's stop the presentation here.